Okay, I started recording. So why we record this video? It's mainly for the marketing, but what I don't like in the marketing of other soft switches, it's like because they don't tell the details. They
Yes, right.
just tell that okay, I have soft switch and this is the price. We have free trial, or marketing like we visit the conference in Chicago or in Dubai and nothing else. So in this, in my marketing, I want to explain the details, how I work, and I like it. So, and this is the first video. In maybe there will be more videos. The quality assurance, QA. This is the most important thing in the soft switches. The soft switch
Yes,
must
right.
be stable, work 24/7 and always, and
Yes, without no interruption.
so no interruption, and the quality is very important. And the first important thing is the quality, not features.
Yes.
It's the stability, the quality, and it's not only about the StarTrinity. It's for every soft switch, for every VoIP software gateway, and why it is easy for me. It is easy because I have the SIP tester. And
Yes,
using the SIP tester, I generate test codes and measure the quality. It's my main product right now. So the code generator. What is quality of soft switch? The quality, how I understand now, it's the uptime. How much time the soft switch is able to work without crashes, without bugs, without interruptions. How many calls processed? What's the maximum volume of calls per second, and number of concurrent calls? These are two main performance limits.
right.
What's the operating memory consumed, and what are the delays? The delays,
right.
The delays between SIP and in RTP. The SIP delays, it's good if the SIP delays are less than 100 milliseconds.
100 milliseconds, yes.
It depends on the application, but in general it is so. And the RTP, the delays in RTP must be less than, well, let's be 30, less than 30 milliseconds. And there are much more RTP packets than SIP packets. You should already know.
Yes.
The audio information is much. The size of audio information is more than SIP. And RTP is most complex thing to implement. Okay, there are self-tests inside this soft switch. The soft switch measures its own delays inside RTP thread. There are multiple RTP threads, and the soft switch measures the delay, and it measures this SIP delay, its own delay. This is self-test. So right now the test is running. So here's the customer's server.
Customer server, yes.
We see it here. It shows the consumed memory. So if this memory grows, it means memory leak. And this is a very complex bug. It's complex to find, to locate the memory leakage. Do you know what's memory leakage?
Can you explain a little bit?
So why I don't like Linux and why I don't like C++. I use C++ only in a place where it is necessary. For RTP and for low-level C processing, I use C++. And in C++, I'll show you a piece of code. So, for example, this real-time audio verification. There is memory allocation in C++. We're using word need. And in C# you don't have to delete this memory. You see here I allocate memory, and this is destructor destroying of the verifier, and here I delete this object. So for every allocation there must be this deallocation of the memory, and it's only one reason for me not to use the Linux and C++. For the entire code, and I prefer using C# for the complex logic. So there are many places in code where I allocate memory and where I free memory, and it's very easy to forget to deallocate the memory. And if I don't deallocate the memory, it grows. It grows.
It grows,
and it grows and grows, and when it reaches the limit,
maximum,
so it's a crash. It's a very popular problem for soft switches. Also, this is free disk space. Also important to keep an eye on free disk space.
Free disk space is right.
CPU load. This indicator I take from Windows, but it's not always adequate measurement. Sometimes Windows tells me that it's only 10% CPU load, but it is only average value. It does not count very small peak overloads. And the Softswitch media thread is very sensible to peak delays, and that's why this is not enough. If the average load is small and not 100%, there can still be a problem. There can be problem of peak CPU overload, and I measure the peak. I measure delay inside the media thread, and I measure the peak delay, and it's possible to reset this counter. So this is a basic. The GUI thread it's not a web thread. It is from Ziptester. In Ziptester there is a desktop GUI, and I still have this thread. It's just like what I have in the system, and I need it. It's not doing the GUI work in the Softswitch. The CDR writing procedure is allocated in the GUI thread, and I should rename the GUI thread. For the Softswitch, I should rename it. Also, web server delays. So what you reported that there is overload, and another customer from Cameroon they report overloads, and what they report is they report web server overload. When someone tells me that your Softswitch is slow, they talk about the web server delay. When we refresh a page,
it takes time to load.
work of web server, and I have a subsystem in the Softswitch which measures every HTTP request and measures the time. And so it's a good time. It's a good time, and you see that the CDR is the longest. It has the longest delay.
Yeah, CDR actually has the longest delay
because it's a large page. It's a large page, and actually the CDR data is the largest data in the Softswitch. After that goes tariff price lists. Price lists are also big, and all other data is small data. CDR data.
What about the CDR statistics? That time.
Statistics. The statistics. There have been a problem with statistics, and it has been calculated in the web thread. And when the user refreshes it too many times, it creates too many threads, and the server dies.
Yes.
And that's why I moved the CDR statistic calculation into another special thread, and it's a thread pool actually, a specific number of threads. This system has how many cores? Details. It has six cores.
6 cores.
So okay, on this machine we can allocate 2 cores for CDR statistics, not more. And it should be configurable. I don't remember. So the CDR statistics calculation has been moved from the web thread to another thread, and it is asynchronous for the web. Here I start calculation, it starts, and I refresh, and okay, here it calculates. It processes the CDR database, and the CDR database is CSV file. I don't like the databases for CDRs because I cannot optimize the database. I'm not a developer of database, and if I have a performance problem with CDR, I'll have no solution for that. And I like to control everything. Not everything, but what I can control, I want to control. And the CDR, it's just a one table database, and that's why I only write CSV file, file, and there is no index in this database. And with regular database, I don't know what exactly happens with data, and I'm not sure about loss of call detail records. And here I control the writing, and I feel good about it.
Okay. It's fine. Actually, it gives the correct information most of the time. Like I've been using it for a lot of time now, so it's okay.
Yeah. So all this code runs in C++, and the KPI, key performance indicator for CDR statistics calculation, is time while it is executing, time of execution, and number of calls. This is small number of calls, and it could be million, billion, and this.
Yes, that's right.
This thing runs in C++.
Yes.
In C++, and one more advanced step to improve performance is to port C++ into assembler. Do you know assembler language?
Assembler? Yes, I know a little bit.
Yeah, assembler. So I control this calculation 100%. I don't control Windows API function which reads the file, and I don't want to control the read file function. But the statistics calculation by itself I control. Okay. So next, what we talk about? Self-test.
Self-test.
Simple. This is self-test. And there should be more. These are only basic tests, and there should be more tests. And this simple test that I'm running right now. So yesterday we had a problem with customers. We talk about problems. I want to talk about problems. I don't want to run marketing as like, oh, we have everything working, but it is false. People know that there are problems, and we talk about problems. Well, not about all problems, but at least something. I don't have time to talk about all the problems.
Yes, there's the main problems, like we have to work with every day.
Yeah, main problem is when the switch doesn't work. So there was a problem with licensing. The licensing, I see in the log. Well, what the key performance indicator is presence of error logs. Now it is good in the error log, and there have been errors in the log. I see it here in File Manager. I turned on debugging, and yesterday I saw that there have been an error that it could not connect to the remote server. I have checked all my licensing servers. I have rechecked, and really one server was down, and one of licensing servers I have multiple licensing servers, because if one server goes down, I don't want to stop all the switches.
Right.
So, and if one licensing server goes down, another is up, and I have 4 licensing servers. So licensing is important. It's the way how I see who uses the Softswitch, and if he authorized or not. Authorized by IP address of Softswitch right now. Okay. I see it in log. The log. There is a level of log. You see it is error here, error.
Yes.
And I turned on debug logging. Debugging shows the debugging shows more details than just errors. It's debug. But the logs take disk space, and if I don't want them to take too much of disk space. But I fixed it, and it works. It works, but I used not to believe in the software, and I don't believe that it really works, and I need to test it for a long time.
So it's still testing, right?
So I fixed it works, but I don't believe that it is really okay. It's not okay until I test it for a very, very long time. Okay. So I tested with a SIP tester. This is what I want to show you. So the SIP tester has documentation.
This is generating calls?
Call generator. In the Softswitch, I created originator and terminator for test licensing. I called it test licensing, and I created originator, test routing group, and test terminator, and I used dynamic IP. I generated from Office PC. So this SIP tester runs on my local PC, Windows.
Okay.
And it sends to register as originator, as terminator. It sends a register to this IP address.
Register to this IP address, right? Okay.
So it sends username, password to the terminator.
And it got registered. Yes,
and it is
registered.
It is registered, and it also uses username and password authentication for incoming calls. Here details. This user. Okay. When I publish the video, I will change the password.
Okay.
Okay, it doesn't matter. So I run the test traffic through Softswitch, and I configure the parameters in SIP tester. In SIP tester, there are two ways to configure parameters. GUI. In GUI, you see the number starts with 1 and random digits. Random number and IP. I send the traffic using username and password. This is caller ID, just anything. And this is XML view. And I want my users to use the XML, but new users don't understand it. Looks like programming, but it is an easiest programming.
Yes.
I have created this language call on and in this video I'll talk about XML. So call, it makes a call to number with user with password. There are examples with maximum ring time and quality. This is out of topic. And when the call is answered,
and it
wait for 3 seconds. And this is duration of call, 3 seconds.
Yes, 3 seconds.
And also incoming call. For incoming call, it immediately accepts the call. It is 100% ASR. It's a very simple test, and it plays music. The default music file is 60 seconds long. And that's why call duration is limited by the outgoing calls.
Okay.
Okay, it generates, and you see here five channels.
5 channel calls would be like terminated.
Maximum calls per second. I will give you this tool. If you, I think later you will do this quality analysis yourself.
Yeah, I do some analysis myself.
Yeah, when something doesn't work, you need to test it. And how to test? You can make calls from the SIP soft phone, and you can also make manual calls here in SIP tester, and you can listen to audio.
It will be recorded. I can listen to the audio, right?
And you can connect the live call in SIP tester to sound card also. It is in somewhere in settings. There are too many settings. It's a complex product. It is possible to use a SIP tester as a soft phone also, multi-channel soft phone. But the problem is when it works, but it doesn't work for 100 call. When 1% of call fails, it's a problem, and you cannot generate 100 calls using a SIP phone. That's why you need SIP tester. And
SIP tester, right?
It is used by 600 customers who have purchased it. 600 is a good is a good number, and
yes, of
there is
course,
also a free trial, for 150 total generated calls. There are also free trial users, and I don't know how much. I don't know. Maybe also one more 6, maybe 2,000 total users use it. So it generates and it receives the call. It can also record. And in this test, I just need to generate calls, and I need to make sure that the licensing works. So I will continue running this test for about maybe.
But so far is good, right?
So far is good. Yes. I see status. It's
3 seconds.
3 seconds.
Yes.
And, but why 3 channels? I generate 5 channels.
There is 5 now. I can see.
It changes. Because it is not. It changes every time. So it generates, and we can check it in CDR statistics. ASR is really 100%. 100%. We see it. And yesterday there was licensing error, and it didn't work at all. So I refresh. So we will continue. And I think that the problem was in the licensing server. And right now we work. Developers work on the new licensing system. There is StarTrinity CRM, which the CRM system, it will include licensing as well. So I like to redesign the software. It is when I work on the Softswitch, I have redesigned it. On the system, I have redesigned it but 2 times. Redesigned.
Yes.
And now I redesign it for the OSS BSS system, which will run a cluster of Softswitches. Okay, where did we stop? This is simple test.
Simple test.
So I run it, and it should be okay. And what also the complex, not very complex, but more complex test. What we do now? We do the fast RTP proxy media operation mode. And I'll show you another test. It's our StarTrinity internal test. We test ourselves. We develop a new media proxy mode, and we have released the new version, but it's not stable. I have the Softswitch. First, let me show you Softswitch. The Softswitch is here. The service called France 2 Softswitch, and I run. You see 1,000 channels. These are all the test calls, similar test calls. I run it. Okay, it works. What do we see in quality indicators? It's good. It's good. What about the
delays are good? Yeah,
the memory is good. It doesn't crash, and it runs for 3 days.
It's a pretty good time.
It's a pretty good time. And we see calls per second at total average. So what is the new thing that I test here in originator? I have 3 servers in this test. A backup 5 server, it generates calls using SIP tester. Here is backup 5.
Okay.
It generates 1,000 channels with the script. I'll talk about it later here. It generates calls to Softswitch, to France 2. And it sends it to destination, and destination is France 3. So I have many servers, and here I use 3 servers.
Okay.
Here is France 3.
France 3. Okay.
Oh, I see error. What's the error?
There's some error.
Been some error, but it is still alive. I don't know why.
Okay.
It's something related to RTP receiving.
Okay.
Okay, but this test, in this test, I test Softswitch, not SIP tester. This is call receiver. It receives calls. First, I tell you how it. Oh, the bug can. I need to think about why it happens.
Okay.
So it the call receiver, it checks the caller IP address. If it is if it's not good, if the caller IP address is not good, we reject call. It's like firewall. Very simple firewall.
Yes. Yes. It matches the IP. It doesn't work. It rejects with type 03.
Yes. And it waits for some time. This is random time from 100 to 3,000 milliseconds.
Yeah, 3,000 milliseconds.
And with probability 30%, it rejects the call. And it rejects. For rest of calls, it accepts with session progress. This is early media alerting. It waits for another. So wait for random time, and after that, one more probability.
Block probability, yes.
50% of 70% is rejected. Okay, I don't like this error. So my to-do list keeps going. So this is not good. The error.
It's keeping out from the
error in SIP test at France 3. And I don't. How to fix this error? What we need to do? We need to set log level debug.
You're gonna run the debugger for this?
And see what else we see in the logs. Okay. Maybe it is because of loopback audio. Maybe no. Okay. I don't like it. So every time the software contains bugs, it is too complex, and I don't tell that we don't have bugs. Everyone has bugs.
Everyone has bugs. Yes.
A simple Hello World application doesn't have bugs, or calculator application.
Calculator,
have bugs.
But
we have bugs.
Programs,
yes. We have. It's very, very, and very complex. Yeah. So okay, we accept the call. This is like busy. 50% calls are busy, and we play back the audio. This is a very important element. This is echo, audio echo. And exit. Okay, this is not used in the script. I just. It could be play audio. We can play music to caller, or we can play back exact the same audio that is received.
It's back to back. It's like a looping like after one.
And it is not a simple. It's not simple RTP packet echo. It uses jitter buffer and it uses codec. Here, it is G711 codec, and it uses codec and jitter buffer. And after jitter buffer, it sends the audio
Okay.
There are many ways to send RTP echo back, and this callback audio uses jitter buffer and codec.
Okay.
Okay, so this is receiver. It's like it is a simple test, and there could be much more complex tests.
Complex
there could
than
be
that.
schedule. There could be simulation of some real and changing ASR and ACD. Here it does.
You can modify it as you like.
Yeah, it could be modified with 120 seconds. This is maximum call duration here. It could be modified, and it's an easy script, and it doesn't check the called number. It doesn't care about what's the number. It accepts all the calls. Okay. So this is the receiver. This is Softswitch, and in Softswitch, what I test now, what I'm concentrated, it is the RTP proxy mode. It is fast RTP proxy right now. There are many modes. The fastest mode is open RTP, when the Softswitch doesn't doesn't pass the RTP through its IP address. It passes SDP, SDP from C protocol. So, here it is fast RTP proxy, and the fast RTP proxy is a redesign. It is my redesign of the media module, which uses fastest C++ code that I can imagine right now. So I redesigned the media module, and I call it fast RTP proxy. This is a redesign of our and this fast proxy it works for one call. It worked for 100 calls, but when I generate such huge traffic, it doesn't work. What means that it doesn't work? What I mean, on call generator backup 5. On call generator, I'll tell you about the script. I don't use max ring time. I just change attribute name to ignore the attribute. I make call to Softswitch, and when it answers, for some percent of calls, I just play audio music for 120 seconds, 2 minutes. And for 10% of calls, I verify audio. I play audio speech WAV, and I verify audio to see if what I receive from destination, if it exactly matches what I play. I play speech WAV file, and I check, is it the same WAV file? And I measure confidence score and delay. This is G711 codec, G711A codec, and that's why operation mode is exact operation. It exactly compares the memory, and it is fast operation. And it reports the confidence and delay in CDRs. CTester has CDRs, CDRs.
Whatever matches it passes, and whatever doesn't, it get rejected, right?
No, it only displays it to me. It doesn't reject the call.
Okay, I see some error here, 503. So those are rejected calls on the CDR.
Yeah, these are rejected calls.
Mm-hmm.
This is the main screen I use, lowest quality calls.
Oh, okay. Mm-hmm.
In lowest quality calls, I see that here is the confidence, which must be 100%. I see that for these calls, I see SIP call ID. I see that this call has to be analyzed in detail using logs.
Okay.
I need to understand what happens with this call on call generator on Softswitch in fast RTP proxy module. I have SIP call ID to track. I have number to track. And I need to analyze this call, why it is 1%. And there is also a recording of the call in C debug media. You see, in the script there is a debug recording threshold. It means that it records audio for all measurements where the confidence is less than 98. And I go and check the recordings, and I see here are some recordings. I open the recording, and I see, okay, this is good. Well, the file name doesn't contain the confidence. Let me find the 1% confidence call. Where I see all situations. I need to search by call number. So 256. 256. The numbers are random to search. Oh, didn't find. Maybe here.
256.
Here the recorded file. Oh, you see the audio.
Yes, it doesn't really match it.
It's really bad audio. So the algorithm, the audio verification algorithm, really works here, and it really sees that this fast RTP proxy mode doesn't work. Okay, here's the call ID, and here you can go to debug. Go to debug mode, check the logs, what happens. The most important thing is that it gives you the SIP call ID, and without knowing which call is bad, it's not possible to debug.
Right.
Okay, so here is the bad call. We see it fast RTP. Okay, this doesn't stress me much. Why? Because I have normal operating mode and it works.
Okay.
And
yes.
I have because I don't sell this fast RTP proxy mode to anyone. I only test it. I only went. I have a way to debug and there are ways to fix it, of course. Once I understand the reason I fixed. And on LinkedIn, I have published the a post about some information about such debugging.
Okay.
if cancel and 200K are sent at the same at close time, there is a race condition. Race condition bug. This kind of bug is most popular in Softswitch. It is multi-threaded. So you can read about it here. It's a popular race condition bug, and it was a race condition between caller A side, which sends cancel, and the destination B side, which sends 200K. And if they are close, it's a problem, and a hang call appears. Hang call destroys other calls. It's not good. Okay, so here's a test, and what all I have here. First, the lowest quality calls is what I look at. I also have a chart. Report statistics.
The performance chart.
Report statistics for all these indicators. I have a chart. For example, well, the answer delay is random. It is set by script. And what I look at is media thread delay. It is self-test of A side B tester. And media thread, if we look here, it was low and it became high. What happened here? I increased call load. It was 500 channels, and here it is 100.
1,000. 100.
1,000.
1,000.
So it was better, and it became worse. You see that peaks appear, and the SIP tester doesn't handle it doesn't handle it well. Okay. There are settings in SIP tester to optimize this media thread delay. There is fast operating mode in SIP tester, and here it is not optimum. There is not optimal settings, and it could be optimized. Okay. What's the most important chart I have? It is confidence chart. There's a confidence history chart. So 3 days I run this test, and it was okay, 99, 99, okay, 90, what, 97?
98.
It's okay. And here it's a problem. You see, it's a problem. So how many days I had to run the test? I had to run it at least 2 days. Before I get problem. So, okay, here is a problem, and I see it clearly in the chart. And I'm not sure, is it really my problem? Maybe it was a temporary problem in internet.
Yeah, maybe because it got back again, like after that.
Yeah, and I see here how many hours there have been a problem. From 14 to.
It's like 2 hours, around 2 hours.
For 1 hour. 1 hour
right.
problem. 1 hour problem of. It's not a problem of dropped calls. It's a problem of silent calls. As we see in the recording, in this chart I don't see how many calls from this period really have this problem. Also problem here and here. It could be internet. It could be hosting provider issue.
Maybe, yeah. There could be many reasons for that.
many reasons, and I could purchase 3 more servers from, or I could run it on local computers in a local area network. These are servers from hosting provider.
Okay.
I just purchased for testing. To make it because many times when I test the software in local area network, it all works.
Okay.
When it goes to customer, to the hosting provider, to internet, I have problems. So from the start, I have it on not in my office.
Okay.
Better to run, and this is actually test-driven development.
Yeah, it's better to run with a customer, like what they're getting the problems from.
And I would like to get problems before customers, and I run the test. I try to catch the problem before the customer, and I try to simulate like a real life situation. Real call situation. And for example, it's okay with this codec. What do I change the codec? What happens?
729.
Yeah. Okay. This audio verification mode exact will not work with
729.
Yeah.
Okay.
It will not work because it is exact. Well, I work on in parallel. I work on audio verification fuzzy mode, and it's very complex. I use digital signal processing algorithms, so not exact comparison, but I use the signal processing algorithms for another audio verification mode. And so here I have problems. And this test is good. Well, the test is not good or bad. It shows me the problem. And the Softswitch media, WinPickup RTP media is bad because I see problems. And 1 hour problem is really not acceptable.
Right.
Okay. So what else? Is it clear to you what I do here?
Yeah, it is pretty clear, and it's fascinating. And I think it's good to have tests and everything before it goes to the customer.
Yeah.
And actually,
it's a must thing.
It's must thing because as this is like a huge software and it interlinks with one another, there's more possibility of bugs, so it can be solved at one time,
Yeah. Also, these tests, they don't cover real life situation actually, and
but still you can simulate like a little bit.
Yeah, I can simulate different SIP headers. I could simulate bad packets, but I don't simulate. There could be too much. Well, the call XML by itself is not limited, and it is limited by your idea what you want to test.
Yeah, right. Okay.
And you should understand where the problem can appear, and you should achieve this situation.
Right.
There are QA teams in companies, in software companies, who only do this QA work. Yeah, and also SIP tests are used for unit tests. This is like it's not unit test. Unit test is what is run only one time. This is load tests.
Yes.
And there are also unit tests where there is a scenario and they run one type of test one time. They release
Okay.
new version of PBX or Softswitch, and they run unit tests over the new version, and
Okay.
they understand which test did not pass. Or maybe one unit test could be run, for example, 1,000 calls, 1,000 calls, this kind of test, another 1,000, this kind of test. They use scripts. They have. There are many ways. It's a big area in software engineering. Unit test automation. It's test automation, and also the SIP tester has API to run with scripts. When the script is not entered by you in this interface, the script could be uploaded from the customer from his bat file. There is command line way of using custom scripts, and there is also API in SIP tester. When customer has his own test framework, and they have their
the customer
own
can modify as they want.
Yeah, for every new test they run, they call API methods in SIP tester. Okay, so let's stop the recording, and I hope it will be helpful.
Yeah, hopefully it will be helpful.
It should be helpful for everyone.
Right.
And with Softswitch, it doesn't only test the Softswitch, it tests the server. And the server could be bad.
Yeah, right.
Could be jitter. For 1,000 channels, it could be okay. And 2,000, it's a problem. And every new system must be tested.
Right.
Well, actually, it's a marketing for my SIP tester.
No problem.
I like this marketing. Not like, okay, oh, we have SIP tester, here's the price, okay. So I tell about details. And people who watch this video, if you have questions, you can contact me in LinkedIn. LinkedIn is the best way. In LinkedIn, I see who is the person who writes me. I don't like Skype too much. Skype got worse in recent days, and in LinkedIn, I see who asks me a question. If he's a serious person, I answer. And well,
LinkedIn, you can see the details and whatever the person does.
There are too many people who are not serious. They just they know that the voice RP it's good money, but they don't want to think. They don't want to educate. They don't know English very well, and it's a very big problem. Okay, but we work for clever people who need to know the details, who want to understand themselves. What happens?
I can hear you good. Your voice is breaking.
Okay, let's stop the recording.